embedded world is just about here, but this year's event, like so many other conferences and trade shows, is completely virtual. Embedded Computing Design is the show's official 2021 North American content partner. So Brandon and Rich have spent extra time thinking about how this new era of interaction is, and will affect the electronics industry moving forward. Is it just events that are changing, or is it the entire industry? After, the insiders are joined by Zane Tsai, the director of the Platform Product Center at ADLINK Technology. Zane and Rich discuss the growing demand for AI at the edge and how it is impacting mission-critical applications. They go on to discuss the impact edge AI can have on fiscal capital and human life in general. Later, Tiara Oliver gets to the root of how COVID-19 is impacting electronics and academia labs. What are professors and their students to do without access to labs and equipment? Sid Deliwala of UPenn thinks we should just start throwing labs into backpacks. Learn more in this new segment, Patenting the Project with Tiara Oliver.
Good afternoon. Oh, that's what you say, not what I say. I don't say good afternoon. I just say welcome to another episode of the Embedded Insiders. I'm Brandon Lewis, Editor-in-Chief of Embedded Computing Design, and I'm here with Rich Nass, who is what are you going to be today of Embedded, Rich? What of Embedded?
I can be an attendee of Embedded World, because that's where we are right now, Nuremberg.
A VIP attendee of Embedded World, Rich Nass, who's also the Executive Vice President and Brand Director of Embedded Computing Design. But yeah, you're right, it is Embedded World time. Although this year, it's going to be a little bit different, right? 2021.
Yeah. I mean, talk about nostalgia. The last business trip I took was to Nuremberg a year ago.
You ditto.
And it's definitely has always been my favorite week of the year. I love going to Embedded World. The buzz there is like nothing else that we see in our industry. And I've probably been to 15 of them at least, maybe more. And it's very disappointing that we're not going to have that place to go to. It is a digital event this year. Hopefully we can create some kind of buzz. Certainly won't match what it is when it's face to face, and as you know, Brandon, we are supplying the content for visitors of the United States to Embedded World, and we're very excited about that. So lots of cool stuff going on.
Yeah, I was just thinking, I don't know if I'd call it my favorite week of the year, but it's a good one. I'm very tired at the end of it every year. Hopefully this year I'll be a little bit better rested. But yes, we are doing the content for the North Americas for Embedded World. One of the things, though, that this brings to mind is, as you point out, it's going to be a virtual event. As you point out, there's probably not going to be the same level of buzz. As I think everybody probably knows, however, where we are right now, probably it's not going to go away completely ever. You know, I think at some point we're all going to return back to live events in some form or another. But this virtual element will probably stick around, indefinitely. There's going to be some sort of virtual arm of a lot of shows moving forward. And that probably means that the in-person events are going to be scaled back to some extent. I know that over the past couple of days, you and I have been talking about, man, what has the lack of in-person events done in the industry, just in general? What has it meant for people doing business, making deals, learning about technology? What do you think the impact has been? Do you think it's been that significant? Do you think life is just really going on just online instead of in person?
Well, you touched on a bunch of points, and I'd like to go back about what might happen going forward. And I think events will come back in a pretty similar way that they were in the past. However, with a huge added element that we've been talking about forever. There's no reason why Embedded World should be 4 days of the year only for people who are in Germany or, with access to a flight to get to Germany. It should be something that's year round. It should be something that's global. And I think the Embedded World folks are learning that this year, that it actually can be that. And I think that you'll see a hybrid for this event and for any major event going forward, where it'll be both digital and in person. So anybody can experience what, it's obviously not the same, but anybody can experience it. Okay, so now back to the real question that you asked me. What was that question again?
So yeah, I agree. But the question was, what do you think? What was the question?
How are people getting to the engineer without a live event?
Well, not even just that. Not because we focus on the engineer. Obviously, that's what we do. But there's all of this infrastructure around these engineers. They're all the supply chain and procurement people. They're salespeople. They're marketing people. All of these people, including the engineers, are all impacted by this. Obviously, especially at the event space. How are people going about making the sale? Learning about new technologies, making partnerships, hooking up with new companies, all of those things that traditionally a lot of those things happen at these events. And to your point, yeah, there are going to be a virtual element. You're never going to be able to replace some of that sort of collaboration and networking via a virtual venue that you can in a physical space. But like right now, because that's not available, what do you think is going on in the industry? Do you think people just the deals aren't being made? I mean, that can't be.
Like a lot of things, a lot of small things will have an impact. And we've seen the number of webinars that we produce has grown significantly, and that's one small thing. We're seeing a lot of the vendors doing their own digital events, which they haven't done in the past. That's another small thing. We're seeing a lot more outreach by the vendors. And that's another small thing. If you put all these small things together, that is what is happening. And that's how the vendors are reaching the engineer. It's certainly not ideal, but we don't live in an ideal world. So it has to be.
For sure. I mean, I think one of the challenges that we're going to run into, and those of us who've been in the media space for a while understand this better than most, and most are about to understand this, is that there is such a thing as too much. There's such a thing as noise. And that's one of the benefits of existing in a physical space, is that communications are synchronous. That you have somebody's undivided attention. You can ask them a direct question, and unless they're incredibly rude, get a direct answer. Within this virtual realm, that asynchronous element of it, that, hey, I'm going to send you an email, or hey, I'm going to register for something and maybe I'll attend. Now, especially given the fact that you're dealing with so many people trying to enter this space all at once, I think is a setback on the engineering side. Now, on the actual, get product to market side, all that infrastructure I was talking about that supports, the engineers making the products, I'm thinking that we might hit a little bit of a plateau in terms of some of the innovation that comes out of this, because I think a lot of the partnerships that were in place are probably going to remain in place. There's not going to be a whole lot of new things. And that's in part because, people aren't meeting in person and, collaborating, I guess, but also in part because people are just being incredibly conservative now with their dollars around the pandemic, because there's so much uncertainty.
Well, a couple of things. First, it has to do with more than trade shows. I'm thinking that the FAEs can't even go out and visit their customers.
Right.
So, that as a result of the pandemic, that has nothing to do with trade shows, but it's a result of the same phenomenon. So yeah, that's definitely true. Weird time now, because everybody says everybody's out of work. The economy is doing so bad. The tech market, according to Wall Street, is going gangbusters. So there's money out there to be spent. So that's not really a space we cover, but it's hard to ignore.
The tech market driven by industry giant GameStop.
If you hadn't gotten out yet, you better get out now.
Right. Well, I do know, speaking of partnerships that were already in place, that one of the partnerships that has been growing over the last couple of years is NVIDIA partnering with a lot of embedded OEMs and really trying to bring that like parallel computing paradigm and graphics processors down into the embedded space. And they've done a really good job of that so far, coming out with platforms like Jetson that aren't still on the, like the power and performance consumption, performance per watt level that we would consider, the sweet spot of embedded, but they're getting close. And one of the leading partners that they have helping them lead that charge is ADLINK. And I think you had a conversation with them, didn't you?
I actually had 4 conversations with them, and we'll be releasing those conversations once a month going forward. The middle 2 conversations actually involve NVIDIA. They're part of the conversation. But in this first episode with Zane Tsai, we talk about AI at the edge and what the starting point is if you're developing for AI at the edge.
Now, the insiders are joined by Zane Tsai, the director of the Platform Product Center at ADLINK.
Before we start, I always like to make sure we're always talking about the same thing. So when we talk about the edge, for the purposes of this discussion, what is the edge to you? What does that actually mean?
Well, I think edge is a relative term. Well, we often compare it to what we call cloud computing or something else. Well, I think the definition for edge, from my perspective, or what my observation is, where the majority of the data is produced and where the major actions are taken, and also, the action produce values. So it's also where the actual value is generated. That's why I'm defining the edge.
Okay, very good. Now, as it relates to artificial intelligence, what sort of applications are we looking at with respect to doing artificial intelligence at the edge?
I would say the most of the mission critical or business critical type of applications are suitable for this AI category. And for example, something you miss the action that will result in human life lost or some money loss, those kind of applications. Or furthermore, it's like in autonomy driving, right? If you take your turns or you take your stop too late, after the sign is signaled, it will generate some unexpected result. Or in the factory, if you take something from a predecessors in the manufacturing process too late, before it can really going forward in the conveyor or in the next process, then the product can be damaged and there will be defect generated. Those are money loss. Those kind of application are particularly that we categorize that has to be executed or be carried out in the edge.
Okay, so what's the difference between edge AI and some other AI, which I assume would be cloud-based AI? Would that be the other alternative? What's the difference?
Yeah, I think the major difference is it's quite simple. I can use a very simple description for this. The major difference between these two, cloud-based AI and AGI, are AGI is where computing follows data. And the cloud AI is majorly for data go to the computing. So imagine that in the data centers like AWS, Microsoft Azure, they have accumulated lots of computing power, storage, and they're waiting for the data. And the data goes into the cloud to calculate, analyze, and generate logic. Then they apply some actionable information. But in the edge, that's different because edge is where the data is actually generated and where the action is taken. So in the edge AI, there's a lot of actions or computation has to be done right away when the data is generated. It cannot afford to transmit the data back to the cloud through some other 3G, 5G, or even in the Ethernet, through Ethernet. It doesn't have the luxury to wait for a remote computation to generate the actionable information. So in the AGI, the key is to move computation close to the data as much as possible.
Okay. So if you want to perform AI at the edge, what sort of hardware and software is required to do that?
Oh, that's a tricky question. Okay, no.
You weren't expecting easy questions, were you?
No, it's not easy. I say it's tricky because I say, well, let's put it this way. In terms of hardware, we do see there's a trend that there's a booming categories for different AI accelerators, computing cores, including CPU, FPGA, VPU, GPUs, right? And among those hardwares, we observe and let's say we experience some results from combining those computing cores. And we see as the complexity of the edge application grows, there's no single type of processor can handle all of the kinds of the applications and satisfy the demand for AGI in time or in performance. So we see there's a demand for combining different kind of processors into solving a scenario in the edge. So we call it heterogeneous architecture. Okay, because sometimes you see, well, CPUs, central processing units, are good to handle those sequential big tasks in sequence, and GPUs are good in handling small tasks in parallel. And FPGA are flexible in configuring their logic to adapt different demands of IOs. So those processors are combined together to solve the complexity in the AGI demands. And in terms of software, well, when I mentioned this, software is actually a solve for all the applications. When you address this, you need to optimize the operation flow and the performance you can gain from those hardware I mentioned earlier. So it is critical that you have the inference engine that can fully utilize the horsepowers inside the processors, the GPUs, the FPGAs, and if there's an unified way to communicate and synchronize those processors in the execution environment, that is very important for AGI adoption.
Very good. So if I was to put myself in your customer's shoes, where do you start? What's the first step that I should take?
So when you try to evaluate what's to take for your AGI application, I would suggest first you have to analyze your application demand. There's very often that the user or the adapter for AGI, they train the model, the network in the cloud or a huge computing environment. And when they try to deploy those model or train the analytics into the field, they will suffer from how can I get those computing power into a compact or environment challenges space? How do I resolve the demands in a less power consumption or even in mobility environment? So those challenges are generally resolvable by the embedded technologies. So when I say that, so AGI it's not actually a brand new stuff. It actually combines some traditional technologies embedded. How you ruggedize your systems, how you shrink your dimension requirements, how you resolve the ventilation requirements in a challenging environment. So I think this kind of demands has to be analyzed in your application. And also choosing a right combination of the processors will be is also important for the application consideration. So, for example, if you're using some network or modeling in the categorization or segmentation, that actually require different kind of processor to perform to perform the best in your application. So, but in common cases, the software developer for AI models, they're good in optimize this algorithm and to generate a very good result for the model inferencing and tell what is good, what's bad, and type of the objects. They're good at it, but there's challenge for them. How do I choose the right combination of hardwares to host my optimal models in the field? That will be quite challenging questions for them.
Yeah, you definitely raised some challenging points where you have to make sure you pick the right hardware. You have to pick the right processor. You have to pick the right software. Is there one rule of thumb for all this, or is it trial and error? Or is it just start with ADLINK and they'll point you in the right direction?
Well, I think we all see this as actually a very challenging part, and yes, we do. ADLINK can help. And we foresee this kind of complexity in selecting the processors or the combinations of hardware and software. And we do provide some consulting services to our customers. That actually is it's a huge benchmark database. Okay, so we collect all the public networks. That is around 40 or 50 popular ones in the world right now, and we benchmark them based on the different hardware combination and the different batch size, different framework, and different inferencing engine on the different hardware. So you can imagine this is a huge effort and complexity in combining these factors. And we own this kind of database in terms to suggest our customer, okay? In order to suggest our customer, what is the right combination you can choose. So we generate this database in this combination, but we use it reversely, okay? So for example, we have some network like YOLO or SSD 300, and we have the framework based on TensorFlow, Caffe, and we have inferencing engine like OpenVINO or TensorRT, and landing on different processors like NVIDIA GPUs, Altera FPGA, Intel processors, and Movidius VPUs. And this kind of benchmark result can let us know what's the performance you can expect it for the network on a given hardware. Then we will ask our customer. So when you try to do the segmentation or categorization, AI inferencing, what's your expected result for the performance? Maybe it's 30 frames per second with a response time less in some period. And we can seek those results inside our database and list out the combinations in a reverse way, right? Then we can make the suggestion to the customer. Hey, if you try to reach the segmentation using YOLO and you try to reach 30 FPS, here's my suggestion. This kind of combination can reach your requirement. Yeah, so there will be multiple selections, but ADLINK has optimized them in a different way. So we are not only providing this kind of benchmark, ADLINK is also specialized in embedded hardware design. So we know embedded, how to ruggedize things and how to certify things in the regulatory environment.
Now it's time for Patenting the Project with Tiara Oliver.
With students in many places still not able to attend traditional in-person classes, educators and universities are tasked with providing a comparable level of equipment and resources as a normal classroom environment. That's not so hard if all you need is a textbook, a calculator, and an internet connection. It's a little more challenging if you required equipment as an oscilloscope or an RF testing chamber.
Right now, the labs are closed.
That's Sid Deliwala, a professor of electrical and systems engineering at the University of Pennsylvania. He and his colleagues have been struggling to find a way to transition from the pre-pandemic world of hands-on, in-person lab experimentation to today's reality of remote learning.
Our students got more hands-on experience because everybody had something with them on their bench all the time. And we could actually say, here, for this homework, you're going to do this experiment. We went through this dilemma of how to send students stuff that'll make them feel that in a lab.
Yeah, it's a complex problem. Or is it? Let's break it down further.
The most traditional approach is let's send everything to them at home, and then they can feel like that in a lab. And yes, we have the technology. We have the ability to send parts, and now we have ability to buy these scopes that can be plugged into a USB port, and they give you a near lab bench experience.
Okay, it sounds like we might be onto something, or more aptly put, into something. Deliwala and members of the Electrical and Computer Engineering Department Heads Association, or the ECE-DHA, a group of academic faculty in the United States and Canada focused on advancing computer and electrical engineering education, have recently begun work on what they're calling a lab in a backpack. The concept relies on the miniaturization of electronics, consumer-oriented technologies like USB connectivity, economies of scale, and the United States Postal Service or other couriers to consolidate most of the tools an engineering student would find on campus into a low-cost, portable, compact case. Barry Sullivan, ECE-DHA Program Director, explains its merits.
Experiment-centric pedagogy. And this is, again, what we are calling the lab in a backpack. The beauty about electronics in the first place is that you actually can put a lab in a backpack. Things get more interesting when you start going, to higher speed, higher frequencies. But for your basic electronics, you can really do it with some fairly low cost, simple tools. But when you look at, say, what they've learned, and this is over about 20 years of this experimental centric pedagogy, you're actually putting the kinds of tools into a student's hands that allow them to try out things for themselves. And they're actually beginning to function more like practicing engineers as they're going through their education. So when you ask about, how are we doing in terms of preparing the next generation of the engineering workforce, I think this is a big step forward, rather than, say, confining them to what they can do in a lab with their lab partner and letting them operate more like a practicing engineer.
Again, Deliwala.
Your physical lab presence is invaluable, no doubt about it. You go to the lab, you're going to learn much more from people around you, but it doesn't mean you don't have access to it at night, 1 o'clock, when you want to actually understand a homework problem and say, here, I'm actually going to do this op-amp circuit, try its waveform output, measure it, capture it, and that's a whole entirely different way of doing things. So our homeworks are more hands-on than pre-pandemic.
Of course, it isn't a perfect solution, and while you might think that the limitations are on the equipment front, the biggest need is actually replicating that invaluable in-person collaboration only a formal lab can provide.
It turns out that when students are in a lab, there is a lot more that happens. There is a community of students around them. There is a back and forth of Q&A. There is usually a lot of chatting with teaching assistants, instructors, professors that's going on. And we found that that's the hardest part to replicate. And so most of our efforts, after we figured out all the logistics of sending parts and getting them all the equipment and everything that they need to do the experiment is to now build the community so they do not feel less engaged in the material they are learning.
Here, the ECE, DHA, and National Science Foundation are collaborating on the beginning of what's shaping up to be the pandemic equivalent of MOOCs in the form of programs like the Lab Pros Network.
We developed something that's been a lot of fun. It's called the Lab Pros Network, which is all the lab professionals and all the, close to 300 institutions that we have as members, 300 ECE programs in North America.
Says John Yanowak, Executive Director of ECE DHA.
And we get unbelievable attendance at these workshops. And it's all about, the sharing that's going on, who's finding out better ways to deliver curriculum, who's out finding out better ways to, use software, and it's been a tremendous experience, and we're going to continue that even after COVID, and keeping that community alive. A big part of what we do is develop community, and it's keeping that community strong during this COVID period while we're all working and learning from home is critical. That's what I think has been our biggest driver. And we've got a lot of support from the members, from companies, a lot of support from the universities, but we've also gotten a lot of support from the National Science Foundation. So NSF has gotten behind a lot of these programs.
With NSF funding, the ECE DHA is able to keep the community and curriculum element of Lab in a Backpack going. Industry is also getting into the act by providing course modules that are available on the ECE DHA website under a repository called Project Reset, an acronym for Remote ECE Teaching. Sullivan?
So if you look under resources, you'll find the Project Reset page. And in this collection, I'd say, a good portion, maybe a third of what material you'll find there. And these are course modules that we're making available to the whole ECE educational community that address topics in basic electronics. But a good chunk of that material is coming from companies like Digilent, like Analog Devices. Cypress has material on there. But again, it's that evidence of the industry support for what we're doing and how they're helping us deal with this new era of remote labs.
It's very early days for the Lab in a Backpack, but it has a solid foundation driven by partnerships that span academia, industry, and government, at least as far as low-cost instrumentation and experimentation is concerned. But what about the near future when students inevitably want and will probably need more? Back to Dhaliwala.
We never thought that a scope could be packed into a USB port. I think it's a matter of time and things will become smaller, driven by this demand. I think within a matter of few years, people will have an RF vector network analyzer that could be running on a Raspberry Pi 10 that would do the signal processing. I think this will trigger the backpack instrumentation movement that I think students are really excited about.
Thanks for listening to this edition of Embedded Insiders. For daily industry news, videos, and podcasts, visit our website, embeddedcomputing.com.